Alright, today we learn a lot of more things about circles. The first thing here is if there's two minor arcs are congruent, if and only if their corresponding chords are congruent. So you can see here that you got two chords in a circle and they're congruent by way of tick marks. That means that the arcs that are contained by them, this red arc and this green arc right here, have to be exactly the same. So they say solve for x, etc. Well, we know that there's 360 degrees possible in a circle. So if this is 64 degrees, we can take 360, take away 64, and get 296 is left for the rest of the circle. But that means that it's split up into two equal parts, so I can just divide that by 2 and get 148 degrees for each one of these. And I'm going to put that on both deals, and I'm going to put the answer in the picture here. So that's what we got going on for this one. These two guys have to be the same. Again, two chords the same. If this is 116 degrees right here, then this is going to have to be 116 degrees right here as well. And notice that this angle is what they're looking for. It is a central angle, and it's contained by this 116 degree arc, so that's got to be 116 degrees also, because central angles and the arcs contained by them got to measure the same. If this is congruent to this, right, if that's 82 degrees, that's got to be 82 degrees. And same thing here, these two guys are congruent, they're both 9 and 9, so there's 90 degrees right here. That means there's 270 degrees left for the rest of the circle. So it's got to be split into two equal parts. So 135 degrees and 135 degrees also. Down here they give us some expressions now. So it works the other way. If these two arcs are congruent, then the chords have to be congruent to each other also. So 2x plus 4 will equal 18. And we could solve for x. So 2x will equal 14. And divide by 2, and x equals 7. So here, both of these arcs are 115 degrees. These chords have to be the same then. So 2x plus 1 will equal 5x minus 5. I'll subtract 2x over here and get a 3x. Everything's still there. Add 5 and get 6 equals 3x. Then divide by 3 and x equals 2. And here, these guys are the same, so these arcs have to be the same. 2x plus 4 will equal 3x plus 2. It's a pretty simple concept, really. And subtract 2 from both sides, and x equals 2. And then here, the two circles are congruent. They're exact same size, exact same shape. So that means like all the radiuses are the same, and etc. So if this arc is the same as that arc, then any chord contained by that will be the same. So 2x plus 24 will equal 6x, just because the circles are exactly the same. So 24 equals 4x, and x equals 6. Just show a little bit of work for me, right? I don't care if you can do that in your head or not. Just give me an equation and solve that equation. Then we get all these crazy situations right here. If a diameter or a radius is perpendicular to a chord, so as you can see here, this red thing is a radius and it's part of a diameter, doesn't really matter. It's perpendicular to this chord right here. Then that bisects the chord, so boom, boom, right? Those two dudes, the distance from A to X got to equal to the distance from B to X. So there's one thing that we'll use here. Here's another. It says if the perpendicular bisector of chord in a circle, the perpendicular bisector of chord is the diameter or the radius. So if we know that these two guys are the same, basically, then this has got to be a radius or a diameter, you know, depending on what the picture looks like right here. So it's kind of the converse of that situation. And then if in a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. We'll use this guy a little bit later on the old backside of this. So let's kind of get started. And it's about putting information in the picture for us. So apparently I cut off the instructions, even though you have them, I don't have them, so 1 second. There we go. This will make the problem a whole lot easier to do when they actually give us some information here. So it says in circle P, the radius is 13, right? That's good information, and the distance from R to S equals 24. Well, when I put that in the picture, I'm not going to put 13 on this guy because it's split up into two little parts right here. And the distance from R to S is 24. That's a chord. right? Segment RS is a chord, but since that's perpendicular, I know it gets bisected. I'm going to go with 12 and 12 right away. And now I'm going to find each measure. They say find the distance from R to T. Well, that's 12. Distance from P to T. Ooh, this little guy right here. And this from T to Q. Here's the real secret to these problems. It's the old radius problem. And see, they've drawn this in. That is definitely a radius in the picture, but our job is to draw in a radius that's really going to help us, and this one really, really helps us. Let me blow this picture up here for you in a second. Here we go. That picture was so tiny. Now we can kind of see what's going on. See, I've drawn that red thing, and that's a radius, and that's 13 units long. Well, you can see here that the reason why this radius helps us so much is because we get ourselves a little bitty right triangle. If that's 90 degrees, this has got to be 90 because they're a linear pair. And we know this dude was 12, and that's 13, and we're looking for this. Well, that's one of our very popular right triangles, the old 5, 12, 13. So I can put a 5 in right here and answer that question that says, what's the distance from T to P? Well, the distance from P to T is 5, right? So that goes in my little picture, and that was 13. And then they say, what's the distance from T to Q? Well, remember, this whole thing right here is a radius, and it's supposed to be 13. So if this much is 5, then what's left over for that puppy is 8. So the secret is draw in a radius from the center of the circle to one of these points, and you'll get a right triangle out of that situation. So back it up. This was 8. Let's do that again. It says if the diameter is 12, right, so that means that this is 6 right here, and this whole thing is 6 also. They're basically saying the radius is 6. The distance from C to D, where's C? That's this point right here. Bad. C to D is 8, so that's a chord. And what I'm going to put in is a 4 and a 4. They say, and the measure of arc CD is 90, arc CD, so this whole puppy right here is 90 degrees, meaning that since these two dudes are the same, right, that this has got to be 45 and 45. And that says that up here. It says it right here that these two arcs are congruent, right? If this is perpendicular to that, then these two guys are the same, and these arcs are congruent, so that's going to be 45 degrees and 45 degrees. So let's find what they ask. Find the measure of arc DE. That's 45 degrees. That's what we just did. Find the distance from F to D. That's 4. And find the distance from A to F. Well, that's where we need to draw in that separate radius to give ourselves a little bitty right triangle right here. And we know that that radius is 6. So 4 blank 6. We don't really have a cool shortcut for that, so we'll do 4 squared plus the distance from A to F squared equals 6 squared. Remember, 4 is a leg, A to F is a leg, 6 is the hypotenuse. So let's do the Pythagorean theorem since we had a right triangle and solve. Distance from A to F squared equals 20, where the distance from A to F equals the square root of 20, which can be simplified because 4 goes into there, so 5 times, so we'll break it up into 2 radicals, which is really 2 square roots of 5 for the distance from A to F right there. So making yourself handy-dandy right triangles. And this is the other thing that they were saying, that if you've got some sort of two chords are congruent if and only if they're equidistant from the center. Well, this chord is 6 units away from the center because perpendicular is all about distance, and this guy is 6 units from the center. So that means that these two chords are the same length right here. It says if the distance from T to S is 21, and this distance from U to V is 3x, so they're equivalent to each other, we'll say 3x equals 21 to our x equals 7. Real simple. And it works the other way around. If these two chords are the same length, then they have to be the same distance from each other. So if they say these chords are congruent, boom, boom, distance from G to Q is x plus 5, and the distance from E to Q is 3x minus 6. Well, since these chords are congruent, they have to be the same distance from the center, so that means that x plus 5 will equal 3x minus 6. And then subtract x from both sides. and add 6 to both sides, and then divide by 2, and x equals 11 halves, or 5.5.